Hi, I'm Metta Spencer. And I tell you, I'm looking out there at snow, and here it is, April the 21st, and I am shivering. But I'm not going to shiver long because we're going to go to sunny California, where my friend Craig Smith is living on a house which he's about to vacate. Hello, Craig.
Good morning, Meta. How nice to see you.
Yeah, well, this is going to be maybe the last time I'll see this particular room. I see in the background, again, that great big poster about your book, Reaching Net Zero. And I see up on top of the cabinet your hard hat from the days when you were in charge of a construction company, right? So
Yeah,
I
that's
wanted you to put
correct.
it on, but you wouldn't put it on for the camera. Anyway, this is the last of your current series of talks about that book that you and Bill Fletcher did together. I think he's going to be with us next week for another conversation. And then we'll let you have a little holiday for a few weeks as you move from Northern California or from Southern California to even more Southern California, right? You're moving
Santa Barbara,
oh no, you'll be moving north, won't you?
a little bit north, right?
Yeah, a little bit to Santa Barbara from Newport Beach. That's the town where Balboa Island is located, right?
That's correct.
In Newport, right? Okay, so I hope you have a good move. Anyway, here we go. We're going to talk about the Arctic today, and as I just mentioned, of all the things that give me nightmares now, it's the Arctic. So the topic of our conversation is the Arctic sending us a message. And I want to know, is it yes or no? Is that the answer?
Well, I believe it is. And I'm basing that on a lot of new reports coming out in the last year or so about with data on ice melting trends in the Arctic and Greenland and Antarctic. So I'd like to discuss with you today that topic and try to answer the question, is the Arctic sending us a message? So what are some of the signs? Obvious thing is we see less sea ice. There's stories, one of the dramatic ones I remember from 2019 was a situation where the polar bears, with less sea ice, polar bear, that impacts the polar bears hunting because they use the sea ice to catch seals, their primary game. And so starving polar bears were desperate and they invaded the Russian town, Novaya Zemlya. And the reports
that's wow. That's the island where they tested the nuclear weapons up in the
right,
Arctic. Yes. Okay.
The big bomb, as it was.
Yeah.
And so there were reports where there were about 50 bears. They broke into houses. In some cases, they attacked people. They were starving, so they went after whatever they could find. That continues to be a problem. The sea ice disappearance affecting wildlife.
Mm-hmm.
The other thing is that NASA's recent temperature measurements of the planet by satellite show that the Arctic is warming more than twice as fast as the average of the globe. So there's something called, the scientists refer to as Arctic amplification. And I'm going to come back to that in a minute. We'll discuss that a little bit later. But also, as you've noted, I think in your previous programs, pardon me, that permafrost is melting. Mm-hmm. And permafrost melting is an ominous sign. It means that methane can be released and is being released. And that's a very critical factor for future global warming. So why is this happening today, or now, I should say? Well, weather systems transport heat from the southern latitudes to the north. the heat is moved by ocean currents and air currents, and the poles warm and dissipate this heat into space. So they lose heat at the poles, while in the middle latitudes we gain heat. And as that temperature differential changes, in other words, as the poles get warmer, then we have a situation where the currents and both sea and air are modified, and that can cause a number of different changes. Very complex meteorology affecting the jet streams, but causing things that we're all beginning to notice now. Droughts in one place, too much rain in other places, flooding, heat waves, wildfires due in part to droughts and in other parts to release of methane from melting of permafrost, which then causes fires. So these are all things that are involved in the mechanism that end up in melting ice. Now, there's a typical pattern of ice buildup in the Arctic, and it follows a pattern. It goes up in the winter and it goes down in the summer. So in other words, around February or March, near the end of the winter, the ice mass and area is at its maximum. By August, it's at a minimum because of melting. So there've been very careful satellite measurements beginning in 1979 of this phenomena of the total area of the ice. And satellites provide means to make multiple passes and determine the area that is covered with ice. So going back to the first year of such measurements in the winter, there was almost 17 million square kilometers of ice. By the summer of the following year, that had decreased to just about 7 million square kilometers. So about 10 million square kilometers of ice became uncovered. Now, fast forward to now, this winter, which we just ended, we had 14.8 million square kilometers. So it was about 2 million less than when the measurements started in 1979. And the low, which would have been last summer in 2020, was 3.7 million square kilometers. So now, compared to when these measurements first began, we're seeing only half as much ice left covered, or land covered with ice left during the summer period. So dropped from about 7 down to 3.7 last year. And the low point actually was in 2024, what got as low as 3.4 million square kilometers. So that is a trend that's continuing. It's gone up and down a little bit, but the overall picture is going down. Now, sea ice, it's white or light gray, and its surface reflects the sun back, the energy from the sun back into space. So about 80% of the incoming energy is reflected back. But as it melts, less ice is present. The dark surface of the sea absorbs that energy and causes more warming. And naturally, it causes more melting of ice, which leads to more warming. So we're concerned that this decrease in sea ice is a positive feedback effect. It could lead to what scientists refer to as a tipping point, and what we've discussed in the past too, where suddenly things no longer are linear. They start changing, and the effects become more rapid and potentially irreversible. Now, another concern is that sea ice is getting younger. What that means is that the sea ice that survives 3 or 4 years builds up in its height, and it's thicker and less likely to melt. But now the ice is thinner, it doesn't have a chance to build more, and so it's more likely to melt.
Mhm.
Other signs of warming, again, you know about the opening of the Northwest Passage. These days, during the summer months, large vessels can traverse that. They don't have to go around to the Panama Canal. There's some consequences of that, which are kind of intriguing from your broader perspectives, which have to do with world peace. And that is a big Russian military buildup in that area. What do they want to do with that? Maybe that's a defensive measure, or maybe they intend to control shipping through there. Who knows what the Russians could be up to with that. Alaska's frozen rivers and other parts of the frozen north are starting to flow earlier. A very clear sign that things are changing. Another important effect is that the loss of sea ice leads to more damage on the coast, coastal erosions. So we have villages in Alaska that are now not inhabitable. The sea ice acts as a buffer to protect the coast against the onslaught of winter storms. Well, with that changing, some of these villages become uninhabitable, and the occupants have to relocate to higher grounds.
Mhm.
There's also effects on fisheries, and changing of fish migration patterns with warming water.
Mhm.
The consequences of melting permafrost are several-fold. One is observed in many parts of Siberia today, and the Siberian towns in the far north is subsidence, roads subsiding, building foundations collapsing, buildings collapsing or becoming uninhabitable. And then, as I mentioned earlier, some forest fires
Mhm.
were triggered by leaking methane.
Yeah.
So concerning subsidence, Svalbard is a group of islands north of the Arctic Circle, halfway between Norway and the North Pole. And the largest town there has a population of about 2,100 people. And it's a good example of where the Arctic temperature has increased now about 4 degrees centigrade versus the lower parts of the globe at 1.1, 1.2 degrees centigrade. There, the permafrost is melting. You're seeing landslides, seeing buildings collapsing, being undermined, basically, the foundations. I remember reading even they had to relocate the cemetery.
Oh, really? Mm.
So these are more examples that demonstrate that the Arctic is warming faster than the rest of the world.
Mhm.
And the other thing about that is that more precipitation is falling as rain rather than as snow.
Mhm.
So Svalbard estimates they've lost 2 months of winter. They have 2 months less winter than they had in the past.
Mhm.
On the one hand, you might think that would be nice, but on the other hand, it has other consequences. So another thing with satellites, scientists have used satellite observations during the same period in mathematical models to calculate the total mass of ice that's lost. It's a huge number. It's so huge that it's very hard to relate it to anything. 28 trillion tons of metric tons of ice lost since 1979. Actually, that's up through 2017. So it's ongoing.
Mhm.
But what's significant about that is where is this happening? So Arctic sea ice is about almost 8 trillion metric tons. So that would be roughly a fourth of the total. Antarctic ice shells, again, about 7, so roughly about another fourth. Glaciers, mountain glaciers are in the same league, about 6 trillion metric tons. That's from glaciers all over the world, the retreat of glaciers we're seeing all over the world. And the Greenland ice sheet is about half of that amount compared to the Arctic or Antarctic, about 4 trillion tons. And then the Antarctic ice sheet is smaller, only about 2.5 trillion metric tons. But that rate of loss has increased by about 50–60% during the or since the 1990s, so in 30 years.
Mhm.
And it's continuing. And the estimate is that from that melting that's occurred to date, we've seen about 1.4 inches of sea level rise. Now you have to remember that the primary effect on rising sea levels is when the ice that's supported on land melts and goes in and adds to the level of the sea. Floating sea ice doesn't have a significant effect, but it does have a small effect. People oftentimes forget the fact that ice has a lesser density than seawater, otherwise it wouldn't float. And so when it melts and becomes water, it's in effect a more dense substance. So there is a minor effect due to floating ice as well.
Wait a minute, say that again. When the water in the ice melts, it's fresh water. And this is more dense than salt water?
Less
Less dense.
dense. Yeah.
So the
Otherwise it wouldn't float.
fresh water stays on the top.
Correct.
Okay. Now, is
But
this
now-
connected to this? I don't understand it too well, but I watched several of Paul Beckwith's videos. He's a guy in Ottawa that I know a little bit, and he's a meteorologist and climatologist. And he talks a lot about this overturn of the current, because when the fresh water comes out of the Arctic Sea into the Atlantic, it comes to where there's normally an overturn of the water, where I don't know, the water sort of goes from top to bottom there, and that has something to do with the rest of the currents, whether it's the the current that warms Europe. What do you call it? That would have something to do with the addition of more fresh water from the melting ice
Yes, well,
into the Atlantic, right?
that changes the salinity. Obviously, more fresh water
Right.
dilutes the salt water, so it changes the salinity. And I'm not at all an expert on ocean currents and all. I just like to sail on top of them.
Mhm.
But the currents, the ocean currents, are extremely complex. You have levels at one height in the ocean going north, and down below much deeper.
Gulf Stream,
you
the
have
Gulf
going the
Stream,
other
sorry.
direction.
That's the word I was trying to find, is the Gulf Stream.
Yeah,
Right?
that's
Okay.
a good example.
Anyway, finally it came to me. Go on.
So they're affected by salinity, by temperature, by
Mhm.
other phenomena too.
Mhm.
It's just very, very complicated.
But it can apparently happen very quickly when you get to a certain threshold. there can be almost within a year or two or 5, 10 years, a very quick change of ocean currents, which then it's kind of like a ratchet effect. It's irreversible, or at least it'd be very, very hard to reverse
It'd
it.
be very hard to change. Yeah,
So,
yeah.
so that, you want to stay away from that point where, and nobody exactly knows what the point is or how we're close to it. Yeah. I'm
Yeah,
gonna talk
what
further with Paul Beckwith about that, because he's pretty good at explaining it, but I need to have him slow down to let me absorb a little bit of it. Yeah, go on. Yeah.
Well, I was just going to say that that concern has been expressed by other people much more knowledgeable than me, and he may be one of them, that we don't want to see the Gulf Stream suddenly reverse direction. That would have a lot of very severe effects on Europe. It would radically change the temperature of Europe, because the Gulf Stream is one way that temperatures are moderated in the northern parts of the globe by carrying warm water up there. So if it suddenly reversed, I don't know if anybody could even predict what all the consequences would be, but there would certainly be a lot of concern. And like you say, if it reversed, it's not going to get back to the normal very quickly, because we have all this greenhouse gas inventory in the atmosphere, and until we do something about that, we're not likely to be able to change things.
Well, another prediction he does make is about what you mentioned, the albedo effect of the melting sea ice.
Yes.
That he says that he would predict that within 10 years, and maybe as soon as within 4 years, there'll be no summer sea ice in the Arctic.
Wow.
And that, of course, and then that really has ramifications, because, as you say, there's a tipping point where the dark black ocean water absorbs the heat more and more. And then we have to talk about clathrates, but go on, because I'm waiting for you to talk about methane at the bottom of the ocean. That's what's scaring me most.
Yeah.
Yeah.
Well, yes, and you're right about that. The clathrates, keeping methane trapped in that chemical, physical form is a huge inventory. If it's released, even a small part of it, it's going to have a very severe effect on global warming. So the other question that people are beginning to ask more frequently now, that I don't want to add to your worries, but I know you and I are both worried about this, is, are we actually at a tipping point in some of these phenomena? And the one that comes to mind is Greenland. Just like the Arctic, Greenland's ice melts in the summer and is rebuilt in the winter primarily by snowfalls. But now, there's increasing evidence that the winter renewal of the Greenland ice is not sufficient. It's less than what melts in the summer. And if this goes on and on, then eventually there will be no ice in Greenland. So for a number of years now, the summer melt has exceeded what's replaced by winter snowfalls. And perhaps you've seen some videos, there's been some programs that were quite interesting where scientists went on the Greenland ice sheets and looked at the crevices and undermining of the ice, under ice rivers flowing out to sea. And that in turn accelerating the melting of Greenland ice.
Yeah.
Deep canyons that are covered with ice becoming hidden rivers underneath them from the melting and then undercutting of the ice. So that's something else we certainly need to be keeping an eye on. And if we didn't have any other incentive to start taking action on curtailing greenhouse gases, I mean, I think that would be enough right there. maybe on that positive, negative note.
Well,
I'll
okay,
pause
but
for a moment.
I think I'm even more pessimistic than you are. And that's hard to be. I mean, you're not exactly a ball of fun, laughter and fun thinking about these matters. So I wouldn't say you're exuberant about the future of the Arctic, but I think I'm even more scared because I really do not believe that reducing emissions is still sufficient to do the job. If we cut emissions instantly to, a huge amount, it's not going to be enough. And I've spent most of my adulthood working against nuclear weapons because I have felt that the threat of nuclear weapons is the most serious prospect, danger of confronting humankind. And now I think it is not as serious as this problem of the Arctic. I think that even nuclear weapons are not as serious because the severity of the problem, I think, has to be measured by, number one, how bad the consequences would be of a disaster, multiplied by the probability of the disaster and the length of time we have to fix it. Okay, all of those need to go in the equation. Well, the disaster of having the melting sea ice reduce a huge amount of methane in the Arctic is enough it is just as bad, if not worse, than the threat of nuclear war, because the number of people who'd be killed, it could be an extinction event. They say that, something like 0.6 degrees, they expect an increase of about 0.6 degrees from just the melting of the sea ice. And that can happen within a few years. We're talking 4 or 5 years. So an event that's that quick, multiplied by the severity of the thing and the fact that it's so fast, we do not have enough time to, whatever solution there might be, we're not going to have enough time to do it, to prevent that. That's what's scary to me. And because when you get to 0.6 degrees additional heat on the planet globally within 4 or 5 years, that is enough. It's going to run the rest of it all. You're going to release the rest of the methane because it's all going to melt slower, but it's going to come out and it'll be irreversible. So that is, to me, the scariest thing that I can imagine. And we just do not have enough time to fix it. So the permafrost on land is going slower than the undersea methane. And these clathrates, which are kind of crystals of methane and hydrogen and water, water and so on, are down at the bottom of the Arctic Ocean. Now, they're apparently, the Arctic Ocean is generally so deep that by the time this stuff releases, it gets absorbed in the water. So it doesn't get out for a long time. It'll eventually get out, but a long time. But on this, the Siberian shelf, the East Siberian Sea is a very shallow shelf of the Russian landmass, if you will, Siberian landmass. So that's only 30 or 40 meters deep, and it doesn't have time to get absorbed by that. So that stuff is coming up, and I saw images of a ship going through this stuff, and it was like, when you're in a plane and it's going through clouds. I mean, you look out the window and all you see is white cloud. Well, it was like that. It was exactly like that. On this ocean, this ship was plowing through miles and miles, or hundreds of miles, I don't know, of methane boiling up out of the bottom of the ocean.
Don't light a match.
That's right, exactly. It would blow up. And but the thing is, how it is so extensive, and it's coming up out of this bottom of the ocean. Apparently, the bottom of the ocean, there's clathrates down there, and it's sort of held down by actual permafrost that came from the last ice age or something, and it slid down there, and it's like a lid holding some of it down, but there are holes in it, and it's escaping through the holes. And even the permafrost contains methane itself. So you have this stuff coming up, and it is really dangerous. And the worst is, under the Laptev Sea, they found that there's a huge, I believe it's the Laptev Sea, which is somewhat different location. There's a huge reservoir of methane, like just an enormous concentration of methane, and there's way more than is in the atmosphere or on land or anything in the world. So it needs to be kept down. And they think that this thing could blow like a giant explosion, and it could happen instantly. And the people that I've seen, I've interviewed Peter Wadhams, and he's going to be on another one of my shows in about 2 weeks. And Peter Wadhams is maybe the leading, he's among the top leading people studying the Arctic for the last 40 years. He goes there constantly. And he has a book called Farewell to Ice, which is about the melting of the sea ice and the probability that this is going to come out, that it is coming out. But there's a woman, a Russian woman, who leads a regular expedition to the Siberian Sea. Every year she goes through this area where there's these plumes of methane coming out. And she is very apprehensive about the possibility of an explosive event of a huge proportion, which would be catastrophic beyond belief. It would be an extinction event, I'm afraid, most likely. So I was asking Peter Wadhams, what are the possible remedies? I don't see how we have time if the timeline is that urgent, but if we had the time, what would we do about it? Well, nobody's quite sure. And there are various things that they propose. Like he said, of course, for one thing, if you just burn the stuff, it's not good, because you sure don't want that much to add that much CO2. But methane, if you burn it, turns into CO2. So burn it rather than allow it to go into the atmosphere, because it's 26 or 28 times as bad a greenhouse gas as CO2. So if nothing else, just burn it. And that could be done, I gather, if you go through and I don't think I want the job doing it. It's pretty dangerous, but I don't know. I think it could be done. But the other thing, he says, fracking. You could go down and do these sideways drilling. They can drill. So if they could drill into some of these concentrated pockets of methane, if they knew where it was, and pull it out, of course, it'd be great. You could use it then. It's a better fuel than some of the other fast fuels.
It's basically natural gas.
Yeah, and it is a fossil fuel, and it does have bad consequences, but it'd be better than what we normally use a lot. Anyway, so but that would be real big operation, having fracking in that area. But the thing that he didn't want to talk about is, because I asked him before we did this interview, I said, can I ask you about this project to use iron salt aerosols? Because I'd read about it. And he said, let's not talk about it yet, because he said, we don't know enough. And it may turn out to be, if it doesn't work, you don't want to necessarily get people hoping. But I have read, and there is I'll put a link to it if I can find, at the end of the show, I'll put it on the page where I sometimes put references to things. So people can go look at this thing about iron salt aerosols, where you would spray iron salts into the atmosphere, or maybe on the ground too, or something on the ice. Anyway, it combines with chlorine, Now, I don't understand chemistry worth a hoot, but it then would create a combination that would then take some of this stuff down to the bottom of the ocean again. Don't believe a word I just said, because it's all probably wrong, but I don't understand the chemistry. But it looked like iron salts could be the most, and that kind of stuff is very available. Iron salt is everywhere. It's not scarce at all. And you could spray it around, and that could be a solution. So I got in touch with some people. There's a man named Reynaud something or other in Montpellier, France, the university there. And he's going to be on my talk show eventually if I can find another person to join him. But he's one of the two people who authored this proposal for the iron salts. And the website they have has like a PowerPoint slideshow kind of thing with plenty of evidence about their reason to believe that this would be a pretty feasible thing to do. I think you could run around spraying quite a bit of this stuff, and they believe it would have a good effect. I think it's not that different from the whole principle. Well, it is different, but there are also people who believe in, and I'm sure you've read about this, putting iron filings in the ocean to create phytoplankton, which then are going to absorb CO2 and go to the bottom of the ocean, the carbon. Yeah. So I don't understand the chemistry of any of it, but I really want to know more about this iron salt thing, because except for those two things, I don't know of anything else that could be proposed as a realistic solution to this problem.
Yeah, well, I don't know a whole lot about these different concepts that under the broad name of geoengineering. I would be very hesitant to implement one on a broad scale without having some kind of structured pilot project there. You could actually see what the efficiency is or effectiveness, and then what are the side effects. I mean, you're tinkering with forces that we really don't know.
Yeah,
now,
but I agree with you, and I think they would agree with you. I think any of the geoengineers would say, well, we would be apprehensive about doing it, except look at the alternative. If we think that the alternative is something like an extinction event where life forms, not just human, but everything else gets destroyed, then you got to do something. Now, I don't know.
Right. You have to do something. Right? But I thought that was very interesting what you said about drilling as, for example, fracking, although this would be a different type of drilling. Early in my career, we did some work for Phillips Petroleum on their offshore oil platforms in the North Sea. So I spent a number of weeks out in the North Sea on a Phillips platform. It was fascinating. And they're drilling under very deep conditions. And the platform I was staying on actually supported 50 wells, as I recall. So they had 50 wells from this one platform went down and slanting off in all different areas.
Oh, so from one platform, they go out in different directions.
Right. They would. So this is kind of an interesting concept. And the oil companies certainly have the expertise to go to the Siberian, what did you call that?
East Siberian Sea, I think is what, yeah.
Yeah, they could go there, they could set up some platforms and slant drill and collect the methane if it's in a form where it would flow and all. I mean, I don't know all the chemistry of that. But that technology is certainly known and proven, and in shallow water they could do it would be even easier, and they it might be something that oil companies would be interested in because it would give them a stake in the future that they're not going to have otherwise.
Right. Well, now then, but there's also the problem of politics in Russia, because that part of the ocean is mostly or entirely within, it's defined as part of Russia because the shelf of the Russian that's where they say Russia ends, where that shelf
within their economic zone.
That's right. So it would have to be with the permission of, or with the cooperation of the Russians. Maybe they would want to do it themselves. Who knows? But the problem with the Russians is they're in denial. And
yeah,
I mean, unfortunately, they aren't, I don't think they out and out say there's nothing to it officially. I mean, they are part of the IPCC, aren't they? But they're not, I don't know whether, but the Russians I've talked to, certainly with the exception of this woman, I haven't talked to her, but I've seen her talk, and she certainly is very pessimistic. And but most of the Russians I know more or less poo-poo it. They talk about global warming as if, well, it might even be an advantage, because look at all the land that we could. Yeah, there was an article in the New York Times, stupid New York Times people, how could they possibly have printed a thing like that? But they have an article about, I don't know, 6 weeks or so ago, where they talk about how, Russia's going to benefit from global warming because look at all that land that's going to be no longer frozen, and they can raise crops there. Yeah. And it is a huge amount of land. Well, that's true. But imagine do they listen to what's going to happen when that permafrost melts? Yeah. I mean, it's catastrophe. And they didn't even mention that, So
one thing that the Russians do like to do is they like to sell gas to Germany and Europe, and they've got that. I think they finished that second pipeline now, right? So I don't know what the logistics would be to connect the Siberian methane fields to their natural gas pipeline system, but
be really hard.
There might be a market potential there. Who knows? I don't know.
Yeah, I think there could be a market, and maybe, but give it enough time. But how long? It takes a decade to build a pipeline, at least, doesn't it? How long does it take?
Yeah, it takes a while. Yeah, I don't know where the closest connection point would be. I can't visualize it.
And the distance from Europe. I mean, I don't know. Maybe there's another place how they get rid of it. I don't know. But
I just was so impressed with what the oil companies did in the North Sea. I mean, this is like 40 years ago or 30 years ago. I mean, they had undersea pipelines, they had pumping stations underwater. Mm-hmm. And they moved the oil, I forget which way it went. They moved the oil from the North Sea to England, and the natural gas went to Europe. Something that was divided.
Doesn't Norway have most of that? Or I don't know. I know that Norway has a lot of money from.
Yeah, Norway and the UK. Yeah. Basically, when we went there, flew to Norway, then we flew from Norway out onto the platforms in a helicopter. It's quite an experience. I'll never forget it. I'll tell you one little story. One of my engineers asked the pilot, he said, we had to put on these survival suits to get in the helicopter. And so he asked the pilot, he says, you guys ever have crashes? And the guy said, yeah, we had a few. And he says, well, do these survival suits work? And the pilot hesitated for a minute, and he looked at my engineer, and he said, well, we don't really know because everybody was killed on impact. That's as we're boarding the helicopter, getting ready to take off. Anyway, we had no problem. But the other thing that was fascinating to me was once a week, we had a lifeboat drill. And they had on the top of the platform, they had these 4 lifeboats stationed, one on each side, and you had your assigned station. And these boats were enclosed. So they were designed to be lowered into the water in the event of an accident. And one person was stationed inside the boat with an axe. So if the lowering system wasn't working, he chopped this rope and the boat dropped into the ocean from about 60 feet up. And they were supposedly able to cruise through burning oil on the water, but thank God we never had to experience that. Anyway.
Now, is that the platform? Is that similar to this deep horizon thing or whatever it was in the Gulf of Mexico? It's
Right.
the same kind of facility. Is that right?
Yeah, exactly.
Now, were they in the Mexican thing? Did they also have slanted drills that they were going out in different directions, or what?
Yeah,
Or
most
just
of
one
them,
one drill,
yeah.
one well.
Yeah, it's amazing how they do that. I don't understand how they do it, but they can go in different directions and know what they're doing somehow.
Well, environmentalists are just horrified at the idea of drilling in the Arctic. And I mean, my instinct is the same as yours. That and geoengineering give me the creeps. But if you got to do something, maybe that will be driven to it. I don't know.
Well, I mentioned we need to stop emitting, and you're right. It's good. That's a long-term solution, but I put stress on that right now because unless we get people woken up to the fact that we have to stop emissions, we're not going to get anything else done, in my opinion.
Mm-hmm.
But the sad thing about it, which you recognize and why you're concerned, is that we have this huge inventory of greenhouse gases up in the atmosphere. And even when if we stop 100% tomorrow, those gases are there. That's more quote unquote glass in the greenhouse.
Mm-hmm.
And the temperatures are not going to stop, not going to fall instantly. In fact, they're going to keep increasing for a while. And it's going to take dozens, maybe 100 years before that gas is gone by natural causes. So people say, well, we'll suck it out of the air, carbon capture. That's all fine, but we don't know how to do that today. We don't know if we can do that today. We don't know how many thousand plants around the world it would take to do that, and how much energy it would take, trying to suck a very dilute substance out of the atmosphere. It's going to take a lot of pumping power. And then what do you do with it? We got to store it underground somewhere.
Mm-hmm.
And our experience with storing things underground has not been 100% perfect.
Mm-hmm.
So anyway, you can lay awake nights worrying about it. I mean,
people
I know you do worry about it, and I worry about it.
Yeah, right.
We've got to get more people committed. That's the bottom line.
Well, you in a way you don't want to alarm people unless you have solutions. And I think I don't know. I mean, I know that you and Bill say, well, we know what to do. We have the solutions. I don't think the solutions you have are fast enough, and certainly they're not being adopted fast enough. And I think that there's more needed, that in terms of actually sucking it out of the atmosphere one way or another. I don't have much faith in the economics or the feasibility of this direct air capture by machines, but I don't know. I think the most promising for reduction is major agricultural change, because we not only have to have, I think it's not only for the sake of global warming, but because we're not going to have any food unless we do. The very thing that is needed to improve the quality of food production and the amount of food that we'll be able to keep on producing is exactly the same thing that will help us with global warming. So putting more carbon into the soil is the way to go. And I talked to one guy, one of my friends said, well, he's a greenwasher. Greenwashing is anybody who's gives room for private enterprise to, who believes that private industry and so on can make a beneficial difference. So I'm not predisposed to believe one or the other. I think I don't see any reason why corporations couldn't make a good contribution if they wanted to. So I don't rule that out. And this man named Tom Newmark is the head of something called the Carbon Underground. And he's given a couple of talks for me about, and he understands the soil science of how they're discovering more and more things about fungi and things on the roots of plants and how it all works, and that you can do a hell of a lot more sequestering of carbon by agriculture if you know what you're doing. And he has his Carbon Underground. The reason I brought it up is that he says, I said, well, who's going to push farmers to change? Why do you expect farmers would make this very drastic change in the technology that they've always used? My grandfather was a farmer who plowed by hand, until he got a John Deere tractor, which was a great day, he could plow, but he was tearing up the soil, and exposing all this carbon and releasing it to the atmosphere. And he didn't know any better. But anyway, what this guy says is, yeah, farmers will change because they're trying to sell their products to big corporations. And big corporations now know that the handwriting is on the wall. They can't keep on producing food from the soil the way we're ruining it. And that we have to do something to replenish the soil and restore it to the conditions that it was in. So, he says that these companies are the most powerful source of influence to force farmers everywhere to make some real changes in the technology of farming and to do more. And I know that the French about 5 years ago had a project called 4Me, 4 per million, per million is 1,000. So 4 per 1,000, which is, it's not 4%, but 4 per 1,000, small amount. Every year, their goal is their objective is to increase the amount of carbon in the soil by that much. And then if that is done, there's a, very significant amount of influence that will be made on the amount of carbon in the atmosphere. So again, that takes a while though, all these things are going to take a while. And I don't see how, with the clathrate melting, these methyl hydrate things, melting in the Arctic, I don't see there's going to be enough time. And I think we got to do something like iron aerosol sprays or something that can be done quickly and would have an immediate effect.
Well, you said earlier that our recommendations in our book weren't gonna help fast enough, and of course Bill and I agree with that, and I hope we made that clear in the book. We outlined a very ambitious plan that could be done with current technology, that's economic and all that, and by 2050 all we did was get back to where we were by 2020 or by 2000. But our point was we need to make a start, and frankly our hope was that by getting people to recognize it's a problem, then it's going to be easier to try to do some more far-reaching things. So basically, thank you. You've outlined what our next book should be. How do we do it fast? What can we do to have an immediate effect? We need to really start thinking about that. But if we can't get the world awoken to the fact that this is a problem, we have to do something, we won't have any luck trying to sell a faster approach because people don't believe it's a problem. So,
well,
anyway.
yeah, and getting people conscious. I lie awake at night thinking about how to break into this system of denial, how to break
Yeah.
into that system of denial. And I don't really know, because I think we have to make people talk about things more. And it's really hard because people don't want to think about it.
Yeah.
And people want to believe what they want to believe. So they'll listen to somebody who's saying what they like to hear, and they'll believe it. And evidence, or rationality. I'm getting so old, it's showing. I tell you, I'm getting to be very, very cranky and old and mean. I don't trust people anymore, because I see these people making such stupid decisions, and I think,
What's wrong? What's wrong with them?
what is wrong? Yeah, exactly.
I agree.
Yeah. And it's, so the whole thing is, you have to blame it on human beings. Too many of us. Yeah, there we go. Isn't this an upbeat ending to our little conversation, Craig? We've had these little visits for months now, and I've enjoyed it so much. But I must say, this is not the way to end it. We've got to think of something cheerful to say.
So I have to go here in a moment, but I thank you for all that you do, and you should not be discouraged. I think you're a voice and a light in the wilderness, and bless you for doing what you do. And if we had 1,000 more people like you, we'd have probably more people waking up to this. But keep on and don't get discouraged.
Well, thank you. You too. Yeah.
All
And
right.
you say you're going to get ready for your next book. Well, okay. I'll pre-order a copy today.
Okay. All right. Well, you take care. I'll be back in touch as soon as we get organized.
Take care of your health, and have a great, a lot of fun moving house. I'm sure you're going to enjoy that.
All right.
All right. You take care. Bye-bye, Bill. Craig.
Bye-bye.
Take care. Bye.